So today we are still on trig identities, okay? We have certain basic identities. And from this shape, this is a complete circle. We have a center O, okay? So any line drawn from the center to any part of the circumference is radius. So as you can see over here. Now from this point, you can call it point P, if you wish. From this point to this x-axis, we have labeled it with y because it corresponds to the y-axis. And here we have labeled it with x because it is on the x-axis, right? So we have theta as our angle. As we all know, sin theta is equal to opposite over hypotenuse, right? So here opposite is y, hypotenuse is r. Then cos theta, we know that it's adjacent over hypotenuse. As you can see, adjacent is x, then hypotenuse is r, right? Then we have tan, which is opposite over adjacent. Opposite is y, adjacent is x. Okay. Now from this shape, we all know that there is this popular theorem, which is the Pythagorean theorem, which says the hypotenuse squared equals opposite squared plus adjacent squared. Okay. So from this shape, we can see that we have the hypotenuse represented with r. Then we have the opposite to be y, adjacent to be x. So we can substitute these values inside their respective areas. So our hypotenuse is r squared, opposite is y squared, plus adjacent x squared. Now here, last time we looked at how after dividing, when we're proving sin squared theta plus cos squared theta to be equals to 1, we divided through by r squared. Let's try and divide through by y squared and see what happens. So here, we divide through by y squared. So this is what we have, r squared out of y squared equals y squared over y squared plus x squared out of y squared. So in this case, with the lots of indices, we can put these two together to have r squared out of y all squared. Okay. Then we have, this will cancel this one off, giving us 1. Okay. Plus, here we can put them together, as we know, to be x on y all squared. So this is what we have. After the division, we have r out of y all squared equals 1 plus x out of y all squared, right? Now, from what we have over here, you can see that we have sin theta to be equal to y out of r. But here we have r out of y. Also over here we have y out of x. And this over here we have x out of y. Now you can see that there has been a reciprocation over there. Checking this one, comparing this one to this one, there has been reciprocation. So what we do is, let's find the reciprocal of sin theta. Meaning that when we turn sin theta upside down, over here, sin theta, when we turn it upside down, we are going to have 1 out of sin theta, right? And therefore, this is going to turn this one upside down as well, because we are turning them upside down. So we have r on y. Okay? So over here, we have the same applies to cos. If we turn cos theta upside down, we're going to have 1 out of cos theta. And this 1 out of cos theta is going to give us, over here we have x on y, r. So we are going to have r on x. Okay? Turning them upside down. The same applies to tan out of y. If we turn it upside down, we have 1 on tan. And this is going to give us x on y. Okay. Now, in terms of trade, these items here have special names for them. We have special names for them. So 1 out of sine theta is known as cosecant theta, okay? Mostly we shorten it as cosec theta, right?
Yes.
So 1 out of sine theta is going to give us cosecant theta. And in short, we call it cosec theta. In the same way, 1 out of cos theta has a special name as well, which is secant theta. And in short, we have sec theta. Okay? And if we come to 1 out of tan, we call it cotangent. So cotangent theta, and we shorten it as cos theta. So that's what we have. So whenever you reciprocate sine theta, we are getting cosecant or cosec theta. 1 out of cos theta is going to give us secant theta, which is sec theta. 1 out of tan theta is giving us cotangent theta, which we shorten it as cot theta. So when we come back to our problem of the day, r out of y all squared equals 1 plus x out of y. So we could see that r out of y is mimicking something over there, which is r out of y equals cosec theta. So we can replace them with cosec theta all squared. And this equals 1, okay, or 1 over here, plus x out of y, plus x out of y. So from there, we see that x out of y is called theta. So called theta all squared. So when we expand this bracket, we are going to have cosec squared theta equals 1. Okay, then plus cot square theta, and this is why we normally say that cosec square theta is equal to 1 plus cot square theta, or better still, you can also say that cosec square theta minus cot square theta is equal to 1 by bringing this one to this side. Cosec square theta minus is equals to 1. This is another identity from this one, which can be generated from this one. In the same way, we can also say that cosec square theta minus 1 equals cot square theta. Cosec square theta, by bringing this one here, minus 1 equals cot square theta. And this is what we have for our problem of the day. So this is the reason why we have cosec square theta equals 1 plus cot square theta. And I hope this one is very clear.